Our solar system is a bustling neighborhood of planets, moons, and space rocks. Each celestial body moves in a delicate dance, held together by the gravitational pull of the sun. At its heart lies the sun, a gigantic star that provides light and warmth to everything that orbits it. This immense star is the very reason life exists on Earth. The sun is a giant ball of hot gas. It's mostly made up of hydrogen and helium. These gases undergo nuclear fusion, releasing an enormous amount of energy. Its gravity holds our solar system together. Without the sun, there would be no life on Earth. The sun's gravitational force is what keeps the planets in their orbits, ensuring the stability of our solar system. The sun is incredibly hot. Its surface temperature is about 10,000 degrees Fahrenheit. But that's just the surface. The core is even hotter, reaching temperatures of around 27 million degrees Fahrenheit. That's hot enough to melt any known metal. The intense heat and energy produced by the sun drive the weather and climate on Earth. The sun is also incredibly large. It's about 109 times wider than Earth. If the sun were a hollow ball, you could fit about 1 million Earths inside it. It's hard to imagine something that big. The sheer size of the sun is mind-boggling and a testament to the vastness of our universe. The sun is a star, just like the ones we see in the night sky, but it's much closer to us than any other star. This proximity is why it appears so much larger and brighter than the distant stars. That's why it looks so big and bright. The sun's light takes about 8 minutes to reach Earth, traveling across the vast expanse of space. Our sun is a yellow dwarf star. Despite its name, it's not actually yellow, but appears so due to Earth's atmosphere. It's about halfway through its life cycle. The sun has been shining for about 4.6 billion years and is expected to continue for another 5 billion years. The sun is a fascinating and complex object. Its surface is constantly changing, with solar flares and prominences erupting from its surface. It's constantly changing and evolving. These changes can have significant effects on space weather, which in turn can impact satellite communications and power grids on Earth. Scientists are still learning new things about it all the time. With each new discovery, we gain a deeper understanding of this magnificent star that sustains life on our planet.
Our solar system wasn't always here. It had a beginning, a moment when it all started to come together. It formed over a very long time, about 4.6 billion years ago. This immense span of time is hard to imagine, but it's the time scale on which the universe operates. Imagine a giant cloud of gas and dust floating silently in the vastness of space. This cloud was huge, much bigger than our solar system is today. It was a chaotic mix of particles, all drifting in a cosmic dance. Something happened to disturb this cloud, a significant event that would change everything. Maybe a nearby star exploded, sending shock waves through the cloud. This caused the cloud to collapse in on itself, pulling all the gas and dust inward. As the cloud collapsed, it started to spin faster and faster, like a figure skater pulling in their arms. This spinning motion flattened the cloud into a disk, a protoplanetary disk. Most of the material in the disk was pulled towards the center, where it began to form something new. This is where the sun formed, the heart of our solar system. The sun got hotter and brighter as it grew larger, igniting nuclear fusion in its core. The rest of the material in the disk started to clump together, forming the building blocks of planets. Over millions of years, these clumps grew larger and larger, becoming planetesimals. They eventually became the planets, dwarf planets and other objects in our solar system, each with its own unique characteristics. This process of planet formation is fascinating, a delicate balance of forces and materials. The inner part of the disk was very hot, heated by the young sun. Only rocky materials like iron and silicate could survive there, enduring the intense heat. This is why the inner planets, like Earth, are rocky, composed of materials that could withstand the heat. The outer part of the disk was much cooler, far from the sun's heat. Icy materials could also survive there, forming the cores of the outer planets. This is why the outer planets, like Jupiter, are gas giants, with thick atmospheres of hydrogen and helium. The formation of our solar system was a complex process, involving many stages and countless interactions. There are still many things that scientists don't fully understand about it. Each discovery leads to new questions, but we're learning more all the time. With each new piece of data, we get closer to understanding the incredible story of our solar system's birth.
Mercury is the smallest planet in our solar system. It's also the closest planet to the Sun. Mercury is a rocky planet. It has a very thin atmosphere. This means that there's no air to breathe on Mercury. It also means that Mercury's surface is exposed to the full force of the Sun's heat and radiation. The surface of Mercury is covered in craters. These craters were formed by asteroids and comets that crashed into the planet. Mercury has no moons. It's a very different place from Earth. Mercury is a very hot planet. Its surface temperature can reach up to 800 degrees Fahrenheit during the day. That's hot enough to melt lead. But at night, the temperature on Mercury can plummet to minus 290 degrees Fahrenheit. That's a huge temperature difference. Mercury is a fascinating planet. It's a world of extremes, with scorching hot days and freezing cold nights. Even though it's a small planet, Mercury is a big mystery. Section 4. Venus, our toxic twin. Venus is the second planet from the Sun. It orbits the Sun at an average distance of about 67 million miles, making it one of the brightest objects in our night sky. It's often called Earth's twin because it's similar in size and composition to our planet. Both planets have a central core, a molten mantle, and a solid crust. But Venus is a very different place from Earth. Unlike Earth, Venus has no liquid water, and its surface is extremely hostile. It has a thick, toxic atmosphere that traps heat. The clouds are made of sulfuric acid, making the environment even more corrosive. This makes Venus the hottest planet in our solar system. Despite being further from the Sun than Mercury, its thick atmosphere causes a runaway greenhouse effect. The surface temperature on Venus can reach up to 900 degrees Fahrenheit. This extreme heat is consistent across the entire planet, day and night. That's hot enough to melt lead. The intense heat and pressure on Venus's surface would crush and melt most spacecraft. The atmosphere of Venus is mostly made up of carbon dioxide. This dense atmosphere exerts a pressure 92 times greater than Earth's at sea level. This gas traps heat very effectively. The greenhouse effect on Venus is so strong that it has created a hellish environment. This is why Venus is so much hotter than Mercury, even though Mercury is closer to the Sun. Mercury lacks a significant atmosphere to trap heat. The surface of Venus is covered in volcanoes, mountains, and plains. These geological features are shaped by the planet's volcanic activity. It's a very active planet geologically. Venus has no moons, which is unusual for a planet of its size. It rotates very slowly on its axis. A single day on Venus is longer than a year on Venus, taking about 243 Earth days to complete one rotation. It actually rotates backwards compared to most of the other planets in our solar system. This retrograde rotation is a unique characteristic of Venus. Venus is a fascinating but inhospitable planet. Its surface is a scorching, high-pressure environment that is extremely challenging for any form of exploration. Its thick atmosphere and extreme heat make it a very challenging place to explore. The conditions are so harsh that only a few spacecraft have successfully landed on its surface. But scientists are still trying to learn as much as they can about this mysterious world. Understanding Venus can provide insights into the processes that shape planetary environments, including our own Earth.
Section 5. Earth, our Blue Oasis. Earth is the third planet from the Sun. It's the only planet in our solar system that we know of that can support life. Earth is a very special place. It has the perfect conditions for life to thrive. Earth is a rocky planet. It has a liquid water ocean. It also has a protective atmosphere. Earth's atmosphere is made up of nitrogen, oxygen, and other gases. This atmosphere protects us from the harmful radiation of the sun. It also helps to regulate Earth's temperature. Earth's oceans cover about 70% of the planet's surface. They play a vital role in regulating Earth's climate. Earth has one moon. It's the brightest object in our night sky. The moon's gravity affects Earth's tides. Earth is constantly changing and evolving. It's a dynamic and complex system, but it's also our home. We need to take care of it.
Section 6. Mars, the Red Planet's Secrets. Mars is the fourth planet from the Sun. It's often called the Red Planet because of its reddish appearance. This reddish color is due to iron oxide, or rust, on the planet's surface. Mars is a rocky planet with a thin atmosphere. It's a cold desert world. Mars has two small moons, Phobos and Deimos. Scientists believe that Mars may have once been a much warmer and wetter planet than it is today. There's evidence that liquid water may have flowed on the surface of Mars billions of years ago. Today, Mars is a cold and dry planet, but there's still evidence of water ice beneath the surface. Mars is a fascinating planet. It's a prime target for future human exploration. Scientists are eager to learn more about the history of water on Mars and the possibility of past life.